Alright, hi guys. Really quick video here just to show you kind of where this whole definition of a derivative comes from. And we've talked about this in class a little bit. I'm going to show you a visual here on the screen. So let's say at point P on the graph we want to find the tangent line. So here's a picture, you can see the tangent line. To figure this out, what we're going to do is we're going to make another point that's a distance out. We say out at like x plus h. And we're going to create this second point and build a secant line. So here I am creating a secant line with this green line that's going from point P to point Q. And what we're going to do is we're going to take that secant line and just move it in so it gets closer and closer to build this tangent line. And actually, I'm going to write on this graph a little bit here. So this point right here, this point Q that we're looking at, if you really think about it, as far as like where is it at on the graph, it's at this point down below here at x plus h, wherever that is. So this is at x plus h, comma, f of x plus h, if I can write that on there. F of x plus h, that's the x and the y coordinate. It totally depends on what the function of the graph is. P down here, let's see if I can erase all this. P is actually, when you think about it, at the point x and f of x. So if you think about finding slope between these points, and the old-fashioned way of finding slope is we take the y values and we subtract them. y2 minus y1, x2 minus x1, kind of a thing. So if I said I wanted to find the slope of the secant, I'm going to write that down here, slope of the secant, then what I would have to do is subtract the y values and subtract the x values. So the y values would be f of x plus h minus f of x all over, and then it would be x plus h minus x. And if you think about it, you can't really clean this equation up that much other than canceling these x's. You can cancel the x's and get an h left on the bottom. And you get f of x plus h minus f of x on top. And this represents the slope of your secant line. So there's a lot going on the screen up here. I'm going to erase a couple of these things. So we just figured out that the slope of this green line that we can see is represented with this equation, f of x plus h minus f of x all over h. So that's our slope. So if you think about it, what we're going to do is we're going to look at h. H is this distance right here. This is h. It's a random distance. We took a point called x, we went a distance h out, h is randomly picked, and what we want to do is we want to shrink h down to nothing, down to 0. And if we do that, h will go all the way away to nothing, and it turns into a limit problem. That's where this comes from, up here. The limit is h goes to 0. If we shrink h down, it disappears. So watch, I'm going to show you what that looks like now. Let's actually look at what happens when I try and shrink h down. So we'll change our screens here for a second. So I'm going to move this green line and let h go to 0. And watch, the line's going to move in, move in, move in, until q and p meet up. Bam, right there. H is, as this moves in, H is getting smaller and smaller and smaller and smaller until I get to right about there. And that's where Q and H meet up. So, or P and Q meet up. So it keeps going, keeps going, keeps going, right about there. I'm going to freeze it for a second. At this point, if you're looking really carefully, at this point, these 2 points are meeting up with each other so that there is no secant line. Instead, it turns into a tangent line, and that's why it's called the limit as h goes to 0. That distance between the secant shrinks all the way down and turns into a tangent line. So every time we're finding f prime of x's derivative in class, what we're really doing is solving this complicated limit where we're taking a secant, shrinking it down into a tangent. That's where it all kind of comes from. And that's a real general description of it, but gives you a little bit of visual of kind of what's going on. All right, thanks.